Hello, I'm Lemon Kong, and today I would like to do an AP Stats review video of one sample proportion confidence intervals. Enjoy. So before we get on with single proportion intervals, let's take a step back and tell what a confidence interval is. A confidence interval is a tool used by statisticians when you don't know the actual parameter mean or proportion in order to estimate it using a statistic. The confidence interval uses sample information in order to calculate a likely interval for the parameter to fall within. In order to calculate a confidence interval, the information that must be provided are the degree of confidence, usually 90, 95, or 99%, sample proportion or mean, the size of each sample, and either a population or sample standard deviation. The confidence interval uses sample information in order to calculate a likely interval for the parameter information to fall within. Additionally, the proper use of the confidence interval requires checking for a simple random sample using the data collection to eliminate bias, a method for determining the normality of the sample distribution so that a normal approximation can be used, and a check for the independence of samples, usually that the population of n is at least 10 times the sample size n. This allows the use of the approximate sample distribution standard deviation of sigma or s over root n. Remember, neglect while stating conditions on an exam-free response question will lower your grade. First, it must be determined that a single sample proportion is the correct method to use for a given question. If the question gives a single percentage or proportion of positive responses from a sample, then this is usually the correct method. If a question provides directly a standard deviation of the data or states a mean value, then make a confidence interval for sample means. For example, a proportion question may state, in a survey of an SRS of the adult male population, 36 out of 50 men surveyed replied that he uses his television more frequently than his computer. This question provides that 36 out of 50 proportion of replies were positive, and that each sample has size 50, which is the required information other than the confidence level, which is given for all confidence interval questions, and that one sample was used, so a single sample proportion is indeed appropriate. In the prior section, I provided the general conditions which need to be met to construct a meaningful confidence interval. These are the specific conditions for a single sample proportion interval. First, it must either be given or assumed that the data used was obtained from a simple random sample or SRS. This must be true so that the data has no inherent bias and correctly represents the population. If not explicitly stated it should be an SRS, then state the like of, the design should be an SRS or flawless, and proceed with caution. Next, it must be assured that the sampling distribution is roughly normal. This is true when both n times p hat and n minus 1 minus p hat or q hat are both at least 10. If this is met, then a normal approximation can be used for the distribution when calculating the confidence interval. Finally, it must be established that the population is large enough to avoid repeated sampling and provide independent samples. In general, the population size must be at least 10 times the sample size. Because this is usually not explicitly given, assume the condition is reasonable based on the nature of the population given in the question. The fulfillment of this requirement allows the use of p hat q hat over the root of n as the standard deviation. Ci equals p hat plus or minus z critical multiplied by the square root of p hat q hat over n. So what does this mean? Ci, the confidence interval, is the range of numbers which you are confident the parameter falls in. Z critical is a critical z-score which corresponds to the degree of confidence specified in the question. It is found with the inverse norm function on your calculator. PQ is a variance of the statistic, so the square root of PQ is the standard deviation, and that's divided by the square root of n in order to get the standard deviation of the sampling distribution. Okay, let's go through this problem. The problem is, as an example, consider a researcher wishing to estimate the proportion of X-ray machines that malfunction and produce excess radiation. A random sample of 40 machines is taken and 12 of the machines malfunction. The problem is to compute the 95% confidence interval on the proportion and the proportion that malfunction in the population. So let's go through the conditions. It's given the question that it's a random sample, we can take this to be a simple random sample. It's given that 12 out of 40 machines malfunction, therefore PN equals 12, and PQ must equal 40 minus 12, 28. So both are greater than 10, we can use normal approximation. And finally, independence. It's reasonable to assume that there's more than a total of 400 X-ray machines being proportioned, so we can assume independence. So let's plug in the variables. We know that we have a 95% confidence interval. We know that the size of each sample is n equals 40. P hat equals 12 out of 40, which is 0.3. So plug these into the equation, you get confidence interval equals 0.3 plus or minus Z critical. I just memorized this. Z critical for 95% is 1.96 standard deviations, just something you might want to remember. 1.96 multiplied by the square root of 0.3 multiplied by 0.7 divided by n, which is 40. So I simplified that, and the standard deviation you get 0.0725 for the sampling distribution. You multiply that by the Z critical value, 1.96, and you have 0.3 plus or minus 0.1420. Now remember, this is a proportion, so if you want to have the average number out of 40, then you multiply everything by n. So our final result for this would be, we are 95% confident that the proportion of X-ray machines which are actually non-functional is between 0.1580 and 0.4420. Okay, well that concludes this edition of AP Statistics Review, and good luck on your exam.